we like that.
Yeah, the visual. Okay, so let's go through example 2. It's a lot like example 1, for the most part. Okay, so what I want you to do is you go ahead and get started by getting a set equal to 0, and then combining it, finding the least common denominator, and combining it into Alright, so we subtract 4, again, the least common denominator is x minus 3. Okay, so in this case, in the first example, the numerator is just 1, but this time it's 4, so we have to distribute the 4 to the x minus 3, and then I combine them in terms to get down to here. Okay, any questions up to this point? Okay, so the critical values will come from 18 minus 4x equals 0, which is the numerator. And then also x minus 3 equals 0. So for the first one, I'll subtract 18, then divide by negative 4. So that's going to give me 9 halves. Second one, it's just x equals 3. So as I create the number line, and you can think, you don't really have to keep the 9 halves as 9 halves. You can think of it as a decimal, which of course is what? 4.5. Okay, makes it a little bit easier to put that on a number line. If you think of it that way for most people. And so on the left, I could choose 0. In the middle, I probably want to choose what? Probably 4. Okay, that's the only integer between those two numbers. And then over here on the right, I'll choose 5. All right, so when I put 0 in, I'll have 6 over 0 minus 3, which is negative 2. Is negative 2 less than or equal to 4? Yes, that's true. Then when I put the 4 in, so I have 6 over 4 minus 3, which gives me 6 less than or equal to 4, which is not true. So the middle region will not work. And then when I put in 5, I have 6 over 5 minus 3, which is 3 less than or equal to 4, which is true. Okay. So our two outer regions are true. So I'm going to start with negative infinity going to 3 union 4.5 or 9 halves. I don't really care how you write it, to positive infinity. Okay. I didn't do the parentheses or brackets yet because we have to check. Would I have an extraneous solution, or do either the 3 or the 4.5 have to have a parentheses? 3. So 3 does, because the 3 would make it 0. Okay. So I'll have parentheses here, and then I'll have a bracket with the 4.5, and of course, remember, you can always put parentheses next to the infinity symbol. Okay? Now, what type of inequality would you not ever have to check for extraneous solutions? What type of rational inequality would you not have to worry about this? The extraneous, the last step. Can you think of one? Okay. I can think of one, so I'll tell you. If you don't have the equal to with it, okay? If it was just less than or just greater than, it wouldn't be an issue because you would just put parentheses there anyway. So it's only when you have the equal to, that's really where you have to worry about that last step to make sure that you can actually have a bracket and not. Okay? All right.